All right, so let's take a really quick look at assignment 2. So with assignment 2, you're spending all your time writing a class. That class is defined in include 6771 Euclidean vector. God damn it. And this is the whole class as we've given it to you. It's wrapped in a namespace, just like assignment 1. And then we have 2 classes inside here. One is a Euclidean vector error class that inherits a runtime error. So this is a custom exception. And you can see that we have essentially said that when you construct it with a what, that we just delegate that. It's a delegated constructor to the super types what. So pretty much just a pointless. It's nearly like a type def. It's just here to give your exception a name, even though it just totally inherits the runtime error type. And then we have an actual class, which is the data type you're working with, which has a public section and a private section. And the private section just consists of this one data member. You can add more, which is a unique pointer, which is a topic of next week. And it's not going to slow you down, because unique pointers are a bit of a separate concept. Your job in this assignment is to write a series of constructors. You need to write a constructor that has no parameters and constructs a Euclidean vector. You need to write a constructor that takes in one parameter and constructs a Euclidean vector full of zeros that many times. So Euclidean vector 10 would give you a vector with 10 zeros in it. You need to have a constructor that will do int amounts of doubles. So if you do 10 and 1.1, it'll create a vector with 10 1.1s in it. We also have other things like iterators. So we want you to be able to pass in an iterator to the beginning and the end of another container and construct a Euclidean vector. So if you have a vector or a list or a doubly linked list or anything, you should be able to give an iterator to the start and the end of that and correctly populate your Euclidean vector. We want you to be able to give your Euclidean vector when you construct it and initialize a list, just like a vector, and it will construct it. This one we haven't done much in lectures on, but it's pretty straightforward to figure out if you read through the docs and look at some examples, so that one's a little bit of fun. And then we have copy and move constructors. So copy and move constructors are probably a little bit more of a topic for next week. Yep. You can do them now, of course, but like that's kind of what we talk a bit more about next week. There's some information about what we expect you to do for the destructor. And then we get into a whole bunch of operator overloads. We have operator equals, operator. We have a copy assignment, a move assignment. We haven't done move assignments. That's next week as well. We have subscript. We have unary plus, negation, compound addition, like all the different kinds of operators on it. And then we have both a vector and a list type conversion. Right? So these are all different ways of like converting your Euclidean vector to a list or to a vector. So lots of different operators here. Besides those, we also have some member functions that aren't operator overloads, they're just functions. That includes the .at operator, which is similar to a vector. Another .at operator, which is for non-consts, I believe. Dimensions to figure out the size of the vector. And then we have some other operator overloads that are friends. Plus, minus, equals, times, output stream, stuff like that. We also have a few utility functions, which this part can be a little bit challenging for some. But these are essentially functions that are kind of like friends. They're not really, they're not really friends. They're still inside the 6771 namespace, but they're not part of the class. So these are things like finding the Euclidean normal, the unit vector, the dot product. If these are concepts that are assumed from your time doing maths, but if these things kind of elude you because you just don't remember them very well, then you can obviously just touch up on them. A quick Google will help with that. There's a little bit of information on your data members here. I'll do a little bit quick demo about that just to fill everyone in. That's just saying what do we expect you to have in your private data members. Then we have a bit on throwing exceptions. So we expect you in this assignment to throw an exception which is your the custom defined exception that we put in your code, and we expect you to throw it in a series of cases. So the last column in a lot of these tables, it's like the name of the thing, the operator, a description of what it does, how you use it, and then an exception. And if it says NA, then it doesn't throw any exceptions. And if it has stuff, then it potentially throws exceptions. And you can see that this one, let me find an easier one, something that's really obvious. Yeah, so let's say you're trying to add two Euclidean vectors together. When you try and add two Euclidean vectors together, if the dimensions of those Euclidean vectors aren't the same, i.e. if you're trying to add a Euclidean vector with 3 items to one with 4, then it should throw an exception. And what it's saying here is that if A's dimensions is X and B's dimensions is Y, just as variables, you throw an exception when they're not the same, when the dimensions are different. And then what you throw is dimensions of LHS X and RHS Y do not match. Now I'll make this really, really, really clear to everyone. The X and the Y in all of these exceptions, anytime there's kind of like a wild card here, like index X, they're all pretty much X and Ys. Anytime you see that, we're actually expecting you to replace that with the number. So in this one here, dimensions of LHS and RHS, we actually expect you to be like 3 and 4. So the actual exception text we will see from you will look like that. LHS 3 and RHS 4 do not match. That's what we expect. So you'll be throwing exceptions in your class, and when it comes to testing, you'll be catching and testing exceptions here. Other notes, you can read through these. Const correctness. As I said yesterday, we expect all of your member functions to be const correct. If they should be const, they got to be const. If they shouldn't be const, they shouldn't be. In some cases, you want to do both. Fisin says, would we just throw the inherited runtime exception? No, you throw the exception that we give you in the code. So we provided a Euclidean vector expression class for you to throw. When we say you're welcome to throw other exceptions if you feel they're appropriate, I mean, I'll clarify this right here and now. That sentence isn't actually like you can throw something else if you want to throw it instead of that. That's saying, what that's saying is that if you want to throw exceptions in other cases than the ones we specify, you're welcome to do that. So if you want to throw exceptions for, you know, not allowing, I mean, I don't even know. I think we added that just in case someone asked the question, but generally speaking, there's no real cases for that. But if you want to add an extra exception case in, you can. But yeah. So it is throwing the Euclidean vector exception, which is defined in here. So that's the error. So you'll be throwing Euclidean vector error. Anything that, all I'll say about no except is that no except should be put on every single function that has a no throw guarantee. We expect you to test. The rest of the criteria is very similar to iteration 1, to assignment 1, so I don't think you need to worry too much about that. The last thing I just want to show you is probably on this smart pointer thing. So section 7 here, we talk about, we want you to do this. Now, let me just find a random, let me just make a file here really quickly. Oops. Let's just, yeah, this isn't going to be anything exciting. This will just be like int main. Now let's just add this to the CMake file. I'll call this one firesyn in memory of firesyn. And then I'll just add this to the CMake So you make it executable, and then we'll just call it firesyn, and then we'll reload the window. Oops, reload window. Okay, so my firesyn.cpp, in C++, I can do this. I can say double. Oh my god, I've already forgotten how to. Auto b equals double. I don't even use raw arrays in C++ anymore, so I've just totally mind blank how to do this. Let's just try this. I'm sure that's not the right way to do it. Certain, in fact. Maybe you just can't. I don't know. How do you construct a double array in C++? Well, I mean, you can probably do this at least, right? I didn't intend to do this. I just thought let's someone probably knows because they've tried it out. This is what happens when we ban the use of raw C style arrays in a course. I totally forget things. Ah. How do we specify the size? C++ double array. So I did. I don't want to malloc something, I just want to put it on the stack. The weird thing about C++, right, is that, remember in C++, it's like, when you say auto s1 equals standard string like this, you are creating a stack object. When you say auto s2 equals new standard string, you are mallocing a new stack object. Right? So we don't want to go anywhere near the new syntax at the moment. Yeah, you can do double B8. I thought there was a way to do it with auto at the front, but I'm probably just... What? Sorry, give me a sec. Oh no! I have to turn this off in all your code bases. I'm sorry that I released this but didn't realize Clang Tidy's turned on in your CMake list, so you're gonna get a whole bunch of random horrible errors. I just need to disable this and deploy a change. So yeah, sorry. I'll just do that after the lecture. But that's why you get these stupid errors, because this is a thing we had last term that we wanted to get rid of. So I'm updating all the old packages, and I think me and Nathaniel just forgot to do that one. So that built fine, and this program runs, it says hi, and then it prints out 1 because that's what I set it to be. I'm pretty sure you're able to do this, unless I'm crazy. Let's see if I'm crazy. Probably crazy. No, we turned Clang Tidy off for the entire course. It's off in all your other repos, I'm pretty sure. Pretty sure. Yeah, should be off. But I'll turn it off. Oh yeah, you probably don't need that no-lint comment anymore, though it's still good practice. But, I mean, not really. It's still good to make clear that, like, this is not good, but I don't really mind. So, I mean, if it compiles, it compiles. That's as simple as it is. So, with double arrays in C++, you can do something like this, though what you often want to do is kind of malloc these things. But without getting into that, because it's all next week stuff, the thing I want to explain to you is that if you have something like this where you have, say, a double array with 2 items in it, and then on this line I'm going to make another thing called auto C equals standard make unique double 2. I'll keep this even simpler. Like that. The thing I want to stress to allow you to start the assignment and not worry about this for a week is that this here is a very clean abstraction such that you can work with these two things interchangeably. So with this simple program I have here, you can treat this object C here as if it is an actual double array. Okay? So even though the spec has this funny little line here, which needs some context, you can treat magnitudes like it's a C-style double array. Now again, I'm going to get this question. People are like, oh, Hayden, you didn't let us use C-style arrays in assignment 1 and we lost marks on it. Why are we using it now? And the answer to that is simply like, how do you think vector works? How do you think string works? They're all primitive arrays underneath because they're fast. But that's because you're not writing libraries. So there's all these great abstractions out there for you to use. So we don't want you using raw arrays. But in this assignment, you're actually writing a library. You're the library writer in this assignment. So like, what are you going to use? Do you use a vector? Vector has costs involved. It's a lightweight abstraction, but it's still somewhat costly. So we're writing that. So you're creating this Euclidean vector type that's actually under the hood going to be a C-style primitive array, a double array. Yes, and we'll talk more about this next week. But the point is that this line here, C, just like magnitudes, you can treat it like it's a double vector. Like you can literally treat it like it's a primitive array of doubles. You don't need any extra knowledge. You can index it, you can assign to it, you can loop through it, whatever. There's like a few things that you need some context on, particularly copy and move assignment and construction. But that's it. The rest of this you can just go ahead and do. So don't feel handicapped in that way. That's actually pretty much everything I wanted to run through for assignment 2. Are there any last questions people have about assignment 2 that we can quickly answer now? It's not a... So the question was, so it's a matrix essentially. I mean, it's not a matrix, it's a vector. Like, different things. So, like, that's a matrix, this is a vector, these are vectors. It's algebra, sure. Devansh says, oh man, you're probably like, why are you ignoring my questions tonight? I'm sorry, that was just dumb luck. There's no time or space complexity checks for assignment 2. I think the only exception to that is... sorry. It's not that there's no time or space requirements, it's that it's very light. I'm trying to find out where the line is. I feel like there was... Is it 1 second? Maybe I took it out. The thing is that... we will expect all your tests to complete within 1 second. But like these operations are all quick. They're not NP complete problems. They're not n squared problems. These are just like simple operations. So yeah, there's probably some limit to time. I don't know what it is, but the point is like we're gonna set a limit where if you hit that limit, you just did something stupid, And I mean, as in like we'd look at your code and be like, oh no, that's just you're mallocing 7 different things and you got 4 loops going through it. Is there a time constraint? I feel like there's a second. I feel like we said something like you have a second, but a second's like that's like 100 times more time than you'll need. And I don't know where it is. Maybe it's in other notes. I don't know. I thought I remember reading it recently. Anyway, like whether it's there or not, there's no time constraint that requires you to do something special. I mean, in every assignment there's a time constraint. Like we're not going to let your assignments run for like 3 hours. So yeah, there's no time constraint. Speaking of that, your assignment 1s have nearly finished running. It's only been 3 days. So your tutors are starting to mark those now. Anyway, any last questions? Can we make an iterator out of the array pointer? That's an excellent question. No, and I'll add that to the spec because I remember some students asked that same question last year. So one thing you can't do in this assignment, maybe I already added it, but I don't think it's there, is like you can't, you're basically banned from using STL containers. No, it's not written there, but this was kind of implied, and we never had problems with this for a few years, and then someone was just like, oh, I'm going to do it this way, and they were like, you didn't say I couldn't. But yeah, the point is that you can't use STL containers in this assignment, so yes, I'll add that to the spec. So you can't use a vector, you can't just like wrap it in a vector. Can we use standard distance? Yeah, you can use standard distance. You can use anything you want. We're just going to ban STL containers. The point is, essentially, you can't use a vector. Like, you wouldn't want to use, you'd want to, like, if you wanted to use a vector for this, it would be an ordered container. And vector's the only one with random access. Or a standard array, I guess. But, yeah, essentially you can use anything. There's no real constraints besides you can't use the vector and array STL container. Yep, C-style loops, because that's how it works in like the string library and stuff, you know. So we're getting you kind of familiar with how some of these libraries might be implemented to get a better understanding of what's under the hood. Anyway, questions are pretty quiet, so let's wrap up. Thank you everyone for coming tonight. You were told in the tute that loops aren't necessary. I mean, I'd need more clarification on what that comment meant. Maybe you should email me. Well, okay, sorry. Let me touch on this point. So a couple of people have clearly been to Simon's tute today because Simon has most of the tutes. It's not bad to use loops. Loops are fine. You just want to avoid I'm just trying to think about how to phrase it. I'm always very conscious that I'm being recorded, right? Simon has made suggestions to use things like standard span, which is totally fine to do, but you won't lose marks for iterating with a for loop. It's an idea we've floated around with, but it's not something we're putting in the spec this year. So Simon is probably mainly suggesting that because if you can use an abstraction, generally it's a good idea too, right? Like if you can use standard size t instead of unsigned int, and if you can use all these things, then it's a good idea too, because pretty much all abstractions are good, particularly if they're commonplace and well accepted. So yes, you're not going to get punished for using that. Generally speaking, like unless something comes up in a lecture and where like you should do it this way, it's not really considered required. So last thing, Kai says, what about algorithms like standard for each? You can use any STL algorithm. The problem is that some STL algorithms want you to operate on a container or something with iterators, and I'm not going to give you all these different rules. The main thing I'm just going to say to everyone and put it in the spec is that you're not allowed to use STL containers in this assignment. I don't care what algorithms you use. There's some algorithms you won't be able to use. There's some algorithms you will be able to use. You might be able to wrap things into an iterator, all these other things, but the point is that you can't use STL containers. That's the main takeaway from it all. There's no issue static casting things. Sometimes it's unavoidable. But if you have a static casting, you should ask yourself the question, is this an avoidable cast? And if the answer is yes, then don't cast. That's the best approach. Let's push other questions on this assignment to the forum. So if you have any other questions, please post on the forum. One thing I will do, because I've been trying to do this term, I tried it with one course previously. I'll make a, so in the C++ forum, I'll make a mega thread assignment to spec questions. Assignment 2. Please post spec clarification questions here. Please do not post please do not post questions pertaining to your specific solution issues. So what we'll do is we'll have a mega thread on ed, where essentially you can all make comments like, can I use STL containers? And we can basically say no and resolve it. That's all. So that's where we'll put that. Please don't just post random shit there. Like, read the spec first. I mean, like, don't post things that are already written there. But yeah. Anyway, thank you for all the hearts, everyone. Let's wrap up. If you have any other questions, post here. Otherwise, we'll chat next week, which will allow you to do the last 10-15% of the assignment. And I hope everyone has a great weekend. Other than that, I'll send you an email out on Friday with a little bit of a summary of the week. So thanks, everyone. I hope you have a great night. I'll see you later.